Hello friend, welcome to the abstract algebra class. It is class 33. Here we will define coset, which is a concept of group theory. First we want to define coset. Let G with respect to multiplication be a group and H be a subgroup of G. G with respect to multiplication is a group and H is subgroup of G. Let A belongs to G, then the city AH equal to A into H such that H belongs to H. Is called left coset of H in G, generated by A. This concept is called left coset, which it's called left coset generated by A. Also the city HA equal to HA such that H belongs to H is called right coset of H in G, generated by A. Here both AH and HA are called coset of H in G. Note point 1, let X belongs to AH, then X equal to AH, H belongs to H. And Y belongs to AH, then Y equal to A, H1 also belongs to H. It is also left coset. Point 2, P belongs to HA, it is right coset, implies P equal to H dash into A, where H dash belongs to H. Q belongs to HA, implies Q equal to H2 into A, where H2 belongs to H. Point 3, if G with respect to multiplication is abelian group, it is implies, according to the definition of abelian group, and the commutative law hold A into H equal to H into H, A for all A comma H belongs to G. It is the definition of commutative law, which every abelian group must satisfy commutative law. This implies A, H we can write instead of H we can write H. A into H equal to H into A. Point 4, let E be the identity element in G. When E is the identity element in G and H is subgroup of G, then E is also identity element in H. E into H equal to E into H. According to the definition of left coset, E into H equal to E into H, such that H belongs to H. We know that E into H equal to H. Therefore, it is equal. Instead of E into H, we can write H, such that H belongs to H. It is equal to H. Therefore, here EH equal to H. Therefore, EH equal to H. Similarly, we can write HE equal to H. Therefore, every subgroup is itself a left coset as well as right coset, generated by identity element. Point 5, AH equal to AH such that H belongs to H. HA equal to HA such that H belongs to H. A into E belongs to A into H, implies A belongs to AH. E into A belongs to H into A, implies A belongs to HA. Therefore, AH intersection HA equal to A. This implies left coset and intersection right coset is not empty set. It was the definition and points of coset. Thank you.